Troubleshooting is an inevitable part of any creation. Whether your project is for a job, an invention, or merely a classroom assignment, something is bound to go wrong at some point. Without an ability to efficiently troubleshoot, you'll spend more time trying to find the problem than actually working on your project and getting it finished, which, let's face it, is the ultimate goal. Even the best and most famous engineers have to constantly troubleshoot their own work. Inventions are filled with pitfalls and modifications. Nikola Tesla, Lonnie Johnson, Benjamin Franklin, Tim Berners-Lee, all famous inventors and engineers. They spent their lives in the endless cycle of designing, creating, fixing, and reworking. Now, to outline the troubleshooting process, we're going to be using the Divide and Conquer circuit, which is created for ELCT 201 at the University of South Carolina Electrical Engineering program. This circuit is simple enough that we can really delve into troubleshooting without having to worry too much about complex design explanation. Our first step is to break the schematic down into each of its subsystems. Now, a subsystem is a system in and of itself that's part of a larger system which has a more complex purpose than each of the subsystems alone. To determine the subsystems, find your sets of inputs and outputs. Each of the subsystems has a particular function. Subsystem 1 is responsible for the automatic function of the circuit. Subsystem 2 is responsible for the manual function of the circuit, and subsystem 3 uses a transistor to switch the relay contact. Now that each of the subsystems are known, we can start narrowing down where the problems exist. Now, a troubleshooting flowchart is extremely useful, and a general chart such as this can help you get started. Next, you're going to see Leah and Josh delve into each of the subsystems in detail to figure out what's going on and how to narrow down where the problem actually is.
Before we begin troubleshooting, we will first need to calibrate our probes. We can see that the probes aren't calibrated, so we will need to do so. Our probes are now calibrated. To troubleshoot subsystem 1, we will connect channel 1 to the trim pot and ground, and channel 2 to the photoresistor and ground. Whenever I wave my hand across the photoresistor, we can see how the waveform changes. We expect the voltage to increase because the resistance increases. Now I will check the output of the LM324. This is our expected waveform. However, our LED is not lighting up. We will need to check and see if the anode is connected to the output of the LM324. It isn't, so we'll correct that. Now our LED is cutting on and off.
When troubleshooting subsystem 2, the first thing that you need to do is you need to make sure that the circuit is working properly. To do this, you're going to check both push buttons and then check the output from the first subsystem. We have noticed that the first push button for subsystem 2 is not working. So now we are going to go ahead and make sure that the output from subsystem 1 is coming through properly. It is. So now we need to check and see if the second push button for subsystem 2 is working to narrow down the problem. And it is working as well. Now that we know that the first push button on subsystem 2 is not working properly, we will check it with the oscilloscope on its output voltage. We notice that there's no output voltage coming from the first push button. Seeing that there's no power going to the output for the first push button, now we need to check the leads. We see that the lead for the first LED is in there properly. We now see that the one of the leads for the push button is actually broken off, and we need to replace the push button. Once we have replaced the push button, we now notice that the circuit is working properly. Now that we know that subsystem 1 and subsystem 2 are both working properly, we need to check and make sure that subsystem 3 is working properly as well. It is working properly. Now that we know the entire circuit is working properly, we need to check and make sure that the output on subsystem 3 is 12 volts. It is in fact 12 volts.
So, having a plan of action and thinking through the problems in a logical way solves the issues quickly and gets you back on track to finishing your project. Remember, break the circuit down into subsystems by finding the sets of inputs and outputs. Check the signal you are receiving from those inputs and outputs to see if it's what you expect to see. If not, you've got your starting point to narrow down the problem and fix whatever issues may come up.